So you press broadcast and then people just start coming in. Is that how?
Yeah, we've got about the attendees are joining now. Hi everyone. It's a webinar, so we won't be able to see them. We have they're sort of slowly rising. I'm just going to get. Harry, can you see?
Yeah, it says loading.
Brilliant. Okay, so welcome everyone to tonight's webinar, Step by Step Passive House Retrofit with Harry Paticas. We're super excited and pleased to have Harry join us for our webinar. So before I introduce Harry properly, I'm just going to do a quick introduction to Carbon Co-op and People Powered Retrofit, just to let people know what this is all about. So this webinar is one of a series of webinars that we're hosting specifically for the supply chain around retrofit. So we're Carbon Co-op, we're a Greater Manchester-based cooperative organisation whose aim really is to support people to take practical action on climate change through improving their homes. So we started off very much around retrofit, and we've actually expanded to lots of different areas, including sort of smart energy, sort of engaging with local government and national government through sort of creative policy stuff, working with different municipalities across Europe. We're doing some work around energy justice. You know, we're very into open source. We're a member organisation. The project that I'm working on and that this event is connected to is called People Powered Retrofit. So this is a 2.5-year BASE funded project. BASE, which is a government department, has funded 5 pilots for creating a local market for retrofit in different parts of the UK. I think they're sort of clear in sort of BASE that some of the larger schemes of the past, like Green Deal, weren't quite working, and wanted to see what other approaches could be taken to support retrofit to happen at a local level. And so what we're doing to do that is we've created an end-to-end householder service that supports anyone that's interested in retrofit to get advice, to have a home retrofit planner to help them understand what they can do to their homes, to get some design development support to find contractors, support on site, and then we can hand over information about what works they've got done on their home. And so really the point of the events, the series of events that we're having this autumn and next spring, is to really connect with different parts of the supply chain. Lots of you I know are architects, some of you are contractors, some of you are professionals in other areas. I'm going to ask a bit more about you in a sec. But really there's lots of ways that we'd like to engage with you. So we've had lots of interest so far. In Greater Manchester, we've had about 140 inquiries, and that's rising all the time. We've actually got 51 fee-paying clients. We've got 12 clients getting to the tender stage, and that will be going up as more clients get through the sort of have their home assessment, have their design development work done. So it's really, there's a lot of demand, and we really want to support the supply chain to expand. So we really have quite a few bottlenecks, particularly around retrofit coordinators, retrofit assessors. We also want to connect with architects, either to pass clients onto and offer sort of onto them that we can't do works for, but then we could offer specific on-site support around the retrofit aspects, energy efficiency aspects with quality assurance. Or there's sometimes we need sort of architects who could support smaller projects with discrete retrofit work. We are looking for architects and sort of consultants in the Greater Manchester or nearby area. So if that's you, please get in touch. And we're also looking for lots of people in the kind of construction side, general builders, joiners, heat pump installers, and the rest of it. And we're sort of building up our networks slowly. So we've got vacancies open for those positions. So please do get in touch if you think you might be interested in applying. I'll put these links onto the chat in a minute. And also, if you'd just like to stay in touch with us, you could use this form to get in touch. And I'll put that in the chat box in a minute when Harry starts. We've got a ventilation training. We hold different sorts of contractor and designer specific trainings. We've got one around ventilation coming up that we're hosting along with Green Register next year. If you're interested. Sorry for the hard sell, everyone. I just got to sort of tell you about the things that we're doing. I think that's my last slide. That's my last slide. Brilliant. So I will stop sharing. Hopefully I didn't talk too fast and that's useful information to you all. But now I'd like to introduce Harry, which is great to have along. We're particularly interested in his approach to passive house retrofit in a step-by-step way, because we know how tricky that can be and how many people we know who can't do a whole gut and refit of their home at one point and want to take it in a step-by-step way. So yeah, I'll leave you to sort of introduce yourself further, and I'll be here to support.
Great, thank you very much for the introduction. So, hello everybody. I can't see you. I'm sure you're there. And I think the more you chat and Q&A, the better, because at least I can sense your presence. I thought I'd give you a little, just to sort of try and give a bit more of a personal touch in this digital world. I thought I'd give a personal picture of where I'm at. So I'm in what is basically a third bedroom of a house, and it's now a studio. I've been here for the last 9 months. Haven't been to the office at all, and made a very smooth transition to working on Zoom and working remotely. And right at this moment, I've got my wife in the next room teaching Mandarin to two 11-year-olds, and downstairs my son is on Zoom in a debate club. So thank goodness you can all hear me. I hope you can. I'm sure if Annika can hear me, then you all can. So yeah, my name's Harry Paticas. I think I can call myself a retrofit architect. I'm very, very clear that retrofit is what I want to focus on for the rest of my career. I have been practicing what I preach, doing it on my own house, also my mum's house, which you'll see very briefly. And today is going to be a talk about the journey that I've gone on in retrofitting my house. But at the same time, I'm going to give you a few examples of other projects I've worked on, and I'm going to finish by talking about my next steps. So I'm just transitioning between one business and another. And the new business is very much focused on scaling up retrofit and working with schools. So I will talk a little bit about, well, I'll talk a lot about my home and then a little bit about schools right at the end. So I'm going to share screen and start the presentation. Can you just give me a nod if you can see that clearly, Annika? Yeah. So there I am in my living room. So this is a talk about my house, which is a 1970s townhouse in southeast London in Honor Oak. And I'm going to just double check I can move the next slide. Okay, and I want to find out a bit more about you all. And I think before I dive into the presentation, I think it would be really nice if Annika could just release a poll. And we're going to try and find out a little bit about who you are and where you are, just so that you can all see where you are and I can see where you are, and we just get a bit of a feeling for who's here and where are you.
So I've launched the poll.
Great. Thank you.
If anyone can't see it, please let us know using the chat box. People do seem to be answering. We'll give you, there's a few questions, there's 4 questions, so we'll give you sort of about 45 seconds, a minute to answer them.
I guess one question we didn't say is, are you an architect and an interested householder? There's multiples, aren't there? So
yeah, unfortunately, I didn't allow people to pick 2 things.
Yeah, well, it starts to get a bit complicated. So we've clearly got a lot of architects, and I think that's a really great sign, because it means there's increasing interest in the practice of retrofit in architecture. It's also good for Carbon Co-op, because it means there might be some people that can join you. And yeah, and there's quite a few interested householders there.
I'm going to end polling so we can share the results with everyone, and I believe you'll still be able to see them.
Yeah.
Hopefully everyone can see these. Do let us know if you can't.
Well, perhaps we can just summarize very briefly. You want to summarize?
Yeah, sure. So we've got over half of the people tonight are architects, and we've got some consultants. We've got a fair few interested householders and a few others. In fact, if you're an other and you want to say who you are, please do use the chat box, and that would help us know a little more about you. Where are you from? Most people are from the southeastern London. And we've got a fair few in the northwest and the northeast, and quite a few different parts of the UK, but also 8 people from outside of the UK. So please, again, it would be great to know where you're coming from if you're not in the UK. I can see in the chat box someone has said I'm a sustainability certification auditor. In terms of properties, a lot of people live pre-1900s, so 1919 housing, and the same amount almost live in sort of housing between 1990 and 1970, so a lot of traditional housing, and I guess to be expected, fewer in sort of more modern housing. Most people here are homeowners, although there is a fair chunk of tenants and a few others, which I'm glad to see. I put that in there because I actually live in a housing co-op and don't quite easily fit into the homeowner and tenant sort of sections anyway.
Great, yeah, thank you for that. I think that's really, I'm quite fascinated that there are so many people from southeastern London, so it's nice to know that Carbon Co-op's got such a wide reach. I was also quite pleased that when I saw the list of attendees that actually I don't know anybody on that list. I think perhaps 1 or 2 people, so it's nice that there's a kind of, feels to me there's a different group of people that I'm talking to from the usual. So I hope that you can all get something useful out of today, and if there are things that I don't touch on, then by all means put questions in the Q&A, and I'll spend a little bit of time at the end of the presentation before dinner answering a few of your questions. So I think the seeing the what type of property do you live in is a really nice lead into this this slide, because as you can see, I've been working for about the last 10 years almost exclusively on retrofit since I became a certified passive house designer. And when I became a SEF designer, I actually thought I was going to be designing new build passive houses, and I had no idea that I was going to be applying those same skills to retrofit. And I think I've, although one might think that, that conservation architecture, heritage architecture, and passive house design are kind of wildly different activities. One is very much about conserving detail and historic building fabric, and the other is, in some people's mind, about slapping on masses of insulation and kind of really maxing out your U values wherever you can. I actually find the two approaches incredibly similar and close, and where I find them close is that they both actually understand building physics really well. And if you look at the EnerPHit documents, they're actually very sensitive about moisture risk and general moisture robustness of retrofit. So I really feel that the passive house approach to retrofit is very, very helpful. It's not exclusively the only approach, but I think you'll generally find that it's a really brilliant skill to apply to retrofit. That does not mean, though, that we go for passive house levels of certification on all projects. It's clearly not appropriate or not possible. And on this page, only one of those projects can actually get near passive house, and that's the one that says 1978, and that's the house I'm talking about today. So that's my house, and that tiny little figure there is my son, and I'm at the window. One other observation about this is that you can do deep retrofit to historic listed buildings. Historic England are actually very open to doing it, as long as it doesn't significantly harm the building and is sensitive and moisture robust, and more appropriate levels of insulation that work with existing spaces. And the sad thing is that there are buildings such as from 2012 that actually still need retrofit. So, that I think the really important thing there to think about is that anything we're building now, we should be thinking about a performance lock-in. And what I mean by that is we should be thinking very carefully about ensuring that each of the steps we take is robust and long-term, and ideally, although not all the skills exist even within me, but to widely should be doing full life cycle assessment, including embodied carbon of all our decisions. At the moment, I'm doing it in an intuitive way. Been working with Jane Anderson from Construction LCA, got quite a good feel for it, but I think I'd like to get to the point where we have a perfectly interlinked set of spreadsheets that are kind of giving us real quantitative information so that we can make the best possible decisions. So moving on, just thought I'd briefly mention a few projects. So this is an 1840s grade 2 listed townhouse, and we achieved the ACB building standard. And it's actually delivered what it said it would. So we've been monitoring this since 2013, and the energy has been exactly what the HPP said it would, a few percent difference. And we've also got lots of sensors in the house. And with this one, we got down to 2.1 air changes per hour, which is actually quite an achievement for a listed building with chimneys. So we applied learning from that project to this one, and I took a view that we wouldn't do the joist ends because it was quite invasive. When I say it didn't do the joist ends, tape the joist ends to the wall to make them airtight. And we did all the other air tightness measures that you might think of, plastered walls, showing the junction of the wall to the ceiling, etc. We got all those right, and all the junctions around windows and openings. But we didn't do the joist ends, and I worked out that it was roughly about 1 air change per hour. So on this, we got about 2.7 air changes per hour. So that's a similar standard. This is a 1920s cavity wall construction in the New Forest. This one had a little extension added on at the back. And this is in a conservation area. Those windows, which you probably can't really tell, they're triple glazed sliding sash windows from the Green Building Store. And this is EnerPHit. And this was a really challenging project. It's really, really difficult to achieve EnerPHit on a Victorian building. Quite a few people have done it. It is very invasive, and I'm not sure we have to go all that way. I think we can get very near that, but I think driving to that target can start to get a bit arbitrary towards the end. And then this project is a 7-story townhouse near St Paul's Cathedral, and again, similar levels of space heat demand and air tightness. And then here we are on my house. So I'm just going to move the icon so I can see the slides clearly. So given that this talk is very much about step-by-step retrofit, I thought I should say that really, one of the key steps is actually getting a freehold. I lived in a flat in a tower block in Bethnal Green for years, and I always wanted to do retrofit to it, and I just couldn't. I couldn't get permission from the landlord. I tried to change the windows. I was even willing to spend all my time to get a perfect window solution for the whole block, and I just couldn't make any progress on it. And eventually got fed up and thought, right, I've just got to get freehold, and I can do exactly what I want. So really a big initial step was getting hold of a property. And we were going to buy a different house, and the purchase fell through, and we ended up buying a house that was actually quite a lot bigger than we expected. And so we had a much lower budget. And so that has actually colored the last 3 years because we had so much less money. So really we had to do the work more slowly. And actually I did, so nearly all the work in the house, all the design and the construction was done by me on Sundays for about 2.5 years. Slowed down a bit recently. Now, just a small anecdote is that one of the conditions of sale was that the vendor got approval to cut down that large tree you can see in the back garden. Actually, there was another one just in front of that. It was between that one and the back of the house, so it was really big and really shading. And we got approval to cut it down. And there's a story about that, which I'll come back to later on. So it's very easy to see where my house is because this Google aerial view caught the moment that the red cavity wall insulation truck parked outside of our house, which is a kind of amazing bit of fortune for just at least having proof that it's arrived, and so it's there in the middle. So this is a terrace of 10 houses, and then there's another terrace of 10 houses just to the south of that. You can see there, and then there's another terrace a bit further down the road, and another sort of small group of houses behind it, and they're all very similar. So I really hoped that other people would follow in our footsteps, and I'll come back to that. So I'm really interested in context. One of my hero architects is Glenn Murcutt, the Australian architect, and if you look at his drawings carefully, you often see arrows with wind, but it's never just wind. It's a particular direction and speed of wind from the north and a certain kind of humidity or a certain kind of coldness, and he really describes the context of each of his projects incredibly well. And so I think it's just sometimes really worth bearing in mind the local topography, and in this case we're on the lee of a hill, so the wind exposure is actually very, very low. Before we moved into the house, we rented a house on top of the hill near here on Sydenham Hill, and it was just so windy and it was so leaky, and it was quite interesting to move from a very windy spot to a much more sheltered spot. And you know, one of the primary reasons for buying this house was its retrofitability, and the fact that it had really good exposure to useful solar gains to the south. So it's a mid-terraced house. There's a nice little bit of design going on by Gleason back in the 70s, and you can see there's a little bit of stepping down as it goes down the hill and a little bit of shifting forwards and backwards to create a little bit of variation. So it's in 1978, the TFA, treated floor area. I'm not sure quite how extensive everybody's passive house knowledge is, so apologies if that's the case, feel free to ask questions. So the treated floor area is the passive house way of measuring floor area. So we're going to be adding about 9 square meters to the existing house by converting the garage. So it's 3 stories, there's a garage below, a little garden room at the back, which is a utility, living and dining on the first floor, and 3 bedrooms on the top floor. It was in a very poor decorative state, and the neighbouring house is lower and staggered. And if you think about the geometry of that, it creates a number of thermal bridges in the house that cannot be forgotten about. And I quite enjoy the history of building regulations and the history of U values. And when this house was built, the only regulation was that there was a U value of 0.6 in the loft, which is about 100 mil of glass wall that was in there, and that's really all most of these houses have down the street. And I think only a few have been upgraded. You can see the house immediately to the right has still got single glazing on both sides, in fact. So this is actually showing triple glazed windows, and that's internorm windows. So I'm going to labour this point. It's the concept of retrofit readiness. I think it's really, really unbelievably important to not dive into insulation and windows and everything else on your house before you've actually resolved all the building defects and looked at potential issues that might even come up in the next 5 years or so, but that would nevertheless affect the retrofit work. So the retrofit ready works we did were fairly minor. There were a few repairs to the roof, some lead work, and some of the hung tiles were missing. And we've actually just had solar panels put on the roof, 12 panels perfectly fitting that roof. And before we put them up, we got about 4 days extra on the scaffolding. And I'd spotted that in that little verge there, that it was the mortar was very crumbly, and I had a hunch that all those ridge tiles might be a very, very friable old mortar. Very hard to tell from the ground, especially on 3 stories. So I left a few days available to clear out the gutter, to repaint the fascia board, and investigate these tiles. And the tiles on the top were completely gone. It was just crumbly mortar, just sort of hanging on through a bit of friction. So, you know, before those panels went on, we got all those ridge tiles rebedded in, so they're now robust and long term. And the roof is concrete tiles, so they're going to stick around for a very long time. So we now, can pretty much forget about that roof, apart from say the gutter, for the next 25 years, which is the duration of the solar panels. So we stripped out most of the layers before we moved in. We had asbestos, just a few panels, which we got removed. Wanted to make sure all the asbestos was out. And we did all the messy kind of strip out works before we moved in. So, but we did move into a completely unfinished house, and we're still in a completely unfinished house, although there are a few rooms finished, of which this is one, and my son's bedroom is another. So, this is actually not my house, but it's an example of the kind of forensic work that we like to carry out on projects to really make sure we fully understand a house. So the blue comments are moisture related comments. This is actually a step-by-step retrofit in Bourneville that is on site right now and may well become the theme of other talks or visits. I think our client is very open to sharing knowledge. So I think that's something that we can consider in the future. This is a preliminary retrofit feasibility proposal. This is very early days, just to think about junctions and to think about what kind of insulation. And then there's the step-by-step EnerPHit process. If I knew that I was talking to a whole bunch of seasoned PHPP users, I could go into all the intricacies of working with the EnerPHit verification process with step-by-step, with variants. And at the time, I kind of felt a bit alone because I was doing this and there was nobody that I could call to say, how do you do it? How does this spreadsheet connect to this spreadsheet? And with variants, I had windows. You can just see in that image, which is the image of totally pre-retrofit, that there were lots of little windows, and as you know, you name each window and then you say which one is it adjacent to. But then when you put a new window in, you have to in variants because you have to do steps. And in my case, I did 5 key building steps to look at how much energy do we save in each step and what measures do we carry out. And there's a bit of programming that you have to do. So it does need a bit of time to work through. Although having given you the impression that it's very difficult, it's also very rewarding to do. So one of the outputs of that process using the EnerPHit Retrofit plan and the associated spreadsheets from PHPP is that you get a graph like this. And so this shows the existing space heat demand of 220 kilowatt hours per meter squared per year. And then you can see that there's step 1, which is, it says 2 there, but it's 1, 3, 4, and 5. And we are on step 3, so where it says 71% savings. And so we've done pretty massive impact down to that. And when you look at the actual bills, it's actually more like 58 kilowatt hours per meter squared per year. So we're actually under what the estimate was. And I've included this page because this is just quick screen print I just added to just encourage all of you. Really, I mean, I think this should really be done for everybody's homes, for every school, and it's just not done. It's at a school today and they don't do this, despite the fact that they have enormous bills. Is to just set up a spreadsheet, put gas, heat demand, electricity, water, and just monitor it over time and just have a look. Energy companies' bills are not designed to help us. They're not useful. In the main, there might be a few, but I generally experience really bad processes of sharing energy use over time. But this is a really good way of tracking. Plans showing the different steps. Got a bit of sun yelling downstairs, excuse me. You might have forgotten that he was supposed to be quiet for an hour and a half. So we've actually, at the time, this is 3 years ago, we were planning to have 2 rooms downstairs on the ground floor, which is the room on the left. And you can see that there's a studio here and then a bedroom. And we were thinking we'd probably keep living on this first floor. And we've actually changed our mind, partly to do with the very weird protected fire stair issues and fire safety for a 3-story building where you're escaping from upstairs into an open living space, and the fact that we wanted this to be an open plan space. And it started to get into the realm of needing fire doors. So we've actually changed our minds sort of two and a half years into the process, which means I've got to do PHPP and variants all over again. But that's fine. We've still got a very good general steer on where things are heading. And we're now going to be putting our living space down here and opening up this back wall and opening all the way through. So that's the current plan. The retrofit measures that have been carried out are the orange, and they've already been carried out. And you know, in the process of getting to know the building, some really weird things were discovered. So you'll see here in the middle, there's this tiny bit of cavity wall insulation that we discovered that, well, so not, there's a tiny cavity wall, it's just this wide and just running up the building. So we discovered that we can actually fill that. So we thought we might as well, not much difference to be honest, because you've got the thermal bridge coming around it. But then there are other cavities that actually extended all the way through. So in some cases, the cavity continued through to the neighboring building. In some cases, it stopped. So hit and miss. And also the back wall was cavity and the front wall not. So the front wall is hung tiles on blockwork. So a whole range of different kind of construction techniques. And there's also a steel in the middle of this plan here with timber in between. And the joist directions change as you go up the floors. So not really like a Victorian house where you know, I've done a lot of them. So you start to get to know which direction joists go in and where they lap over the spine wall and et cetera, et cetera. This house really needed stripping out and having a look at it. So one of the things that we always do with our retrofit projects is to do an opening up works to really make sure you get in and find out exactly what is going on. So you don't have any surprises when you get further down the line. So the general principle was to start on the front elevation, and the insulation was all put in by me and the air tightness measures. And you'll see here that we've got insulation on the front wall into the reveals of the new triple glazed sliding door and also some returns. And you know, you hear some people say you should return by 900 or 1.2 meters or often to the chimney breast in a Victorian house. In this case, I was more guided by the gut feeling that you know, the size of a board, 600 wide, is probably an appropriate amount. And so I've been actually monitoring that. I've got an infrared thermometer that I use. And so when it's 0 outside, I can zap the corner and have a look at the exact temperature in the corner. And so I've done some walls and not others. And it's actually quite helpful to sort of, yeah, get some direct empirical response about what's happening in the building. So a lot of this is very much about a kind of my experience of it and learning through the process.
I'm going to just interrupt. We didn't discuss actually with questions, but one's just come up that's specifically to do with something you've just mentioned, so I thought I would interrupt.
Great. Yeah.
So the question is, how did you investigate the existing cavity wall and how do you insulate them?
Yeah, well, so you need a boroscope or you just need a largish hole. You can take bricks out, is quite extreme, but perfectly possible. You can drill a hole and you can stick something in it and have a look inside and see if you can pull any insulation out. And usually if there is insulation in there, you'll know fairly quickly. It might have been hit and miss insulation, so it might not have been installed well. So you would probably want to investigate a few locations to be sure. And yeah, I mean, that little piece of wall that I discovered at the front, that was just purely saying what's going on here and asking the question and just noticing that there was a shift from the hung tiles to the brickwork. Did I finish answering that question?
Yes. Yeah.
Okay, great. Shall I continue?
To continue, and
Yeah,
also, I guess if you're happy to be interrupted as well.
Oh yeah, no, actually quite like it. Yeah, I quite like it.
Okay, great. So
everybody's rhythm to sort of get a bit of a change.
Yeah, so if anyone's listening and has specific questions, something Harry's saying as we go along, please do put it in the Q&A.
Yeah, delighted to work like that. So yeah, so so you've just been looking at plans, and here's a section. The front is on the left and the back on the right. Porches, quite challenging. You know, quite quite tricky details where you've got internal wall insulation meeting the underside of the porch. You can see there in this area, and then taping joists as they go into the outside wall, and then insulating past those joists, so pulling up floors and getting in there. Lots of tricky moments. And then you can see we've added a lot of insulation in the loft. And you'll notice that there's a hatch, and it says hatch indicates area of party wall exposed to cold loft space to number 5. So remember I said that the houses are sitting down the hill and slipped. So that just is a reminder that more insulation needs to go on those areas, and that you've got to think about those thermal bridges.
We've actually had someone else just ask, referring to what Harry was just discussing, has he found much difference in the readings taken between the 600mm and the 900mm returns?
No, very, very, very little. Very, very little difference. We're talking like 0.2 degrees or something. We didn't find any evidence that we were getting down near dew point temperatures or temperatures at which you might start to get internal condensation. So absolutely way, like 16 degrees or something, never anywhere near 11 degrees.
And John's just asked, actually, sorry, the question's coming thick and fast now, which is great. What type of insulation is the blue and the orange?
So the insulations are all different. So the color is not representative of a material, it's just representative of insulation. The blue, so the orange in this, can you see my cursor?
Yes.
Yeah, so the orange there on that front elevation, that's all cork insulation. I'm going to come and talk about that a bit more. And the orange in the loft is recycled polyester, which is a kind of has got questions about its fire rating that some people, sort of a little bit dubious about it, but as I understand it, it actually shrinks away from fire and doesn't burn like PIRs. But it's a really nice material to work with. It's very easy to tear and to put into small spots, and it doesn't have any itchiness or anything like that. So I think it's an interesting solution. It's quite a cheap solution, quite cost effective, and we had to be mindful of that. The only thing it doesn't do is decrement delay, which is the ability to reduce the flow of heat from outside inwards. And I think that wood fibers are very good at doing that. We're actually going to do some experiments about that. So that's something else that's going to happen. I'll briefly answer that question about installed on the insulation. Are the windows installed on the insulation or the same location to where the old windows were? So generally we've kept the same window reveals to the outside. So what that means is that we've had to turn the insulation into the reveals. So we do actually have a slightly worse window to wall psi value or thermal bridge, but we designed the windows to ensure that we had enough space around them to bring in a significant amount of insulation, and it actually varies a bit, but it's 20 to 40 mil of cork into those windows. And again, I've been monitoring that, and it's been great. And that means that we've actually ended up with quite nice deep reveals on the windows and inward opening windows. And from the outside, it's fairly consistent, so it's not suddenly a much deeper reveal. Passive house thing.
Yeah, sorry, is that cork diathanite? Or
no, it's not. It's cork board. I'll show some pictures of that soon. So I think if we'd pulled it in, you would have ended up with these giant reveals, and it would have looked kind of a bit odd. And there's a sort of balance to be struck between following perfect passive house doctrine, which would say you have your window in the exact plane of the insulation, which does make a lot of sense from a thermal point of view. But then we're balancing that with external appearance and the kind of the context of the street.
I'm not sure how much you want to be interrupted. We've actually had one more question, but maybe this one for now, and then we'll leave you to carry on for a bit.
I mean, I'm very open, so I've got lots to talk about.
So there's one from Nigel asking, when you made good your roof tiles, did you have felt or a breathable membrane replacement?
Right, so it's a fairly leaky eaves on both sides, and it's the original felt that's not in the best of condition. It's pretty good, but I don't know how quickly it's going to degrade. I just noticed a few slightly friable patches, and we don't have any ventilation at the top in the ridge. we just carried on the same detail. But I know we have a lot of ventilation at both eaves, so that roof is absolutely fine. I should also say that we've got lots and lots of sensors. I've got a sample of one here. So we're using these, which are HygroTrack OmniSense HygroTrack sensors. We've got about 10 of these, 15 of these in the house, and they're wireless sensors. What you're looking at here is a battery in here. This is a little aerial that transmits to a gateway, which is downstairs, which connects to the internet. And then I can bring up graphs and things on my computer straight away based on the data for each of the sensors. And then this bit here is a block of wood. And so there are 2 screws that go into the block of wood. And so they pick up wood moisture content. So I'm measuring temperature, relative humidity, dew point, and wood moisture content. So each of them have got a description of where they are in the house and a code. And it just allows me to know what's going on in all the different places. So we've got some in the loft and some in the insulation.
Okay, we'll leave you to comments
shall
now.
I keep going? So I thought this is quite a useful thing to show. And this is part of what you need to submit for an EnerPHit retrofit plan. And I think it's a really helpful spreadsheet or table really, that helps you think about the different ages of the different building elements of your house, and when were they installed, what kind of maintenance or smaller repairs or indeed replacement is required, and how can that start to inform what measures you take and when. So it takes quite a while to get your head around it. I think this could be perhaps there could be a slightly simpler version of it, but nevertheless, this graph helped me develop sort of some slightly deeper building thinking. So this is a little sketch I did for that retrofit project in Bourneville that I mentioned earlier on. And this was me thinking about the whole carbon history of the house from when it was built in 1900 through to the start of retrofit works, which actually is in 2020. And then it's sort of, what about its next 60 years? So there's me thinking, okay, well, there was coal and timber and coke, and then a series of gas boilers, and then where are we going now? Is it a heat pump? Is it radiant heating? How many solar panels can they get on their roof? You know, what are the emissions of the retrofit project? And just trying to put everything in context. So in order to do that, we then actually quantified everything, and we imagined different repairs taking place at different times. And we actually managed to get a real version of that. So that was just a sketch. So this was just me making it up. And this is actual kind of real values. And so we've got a full carbon history of the building. So then back to my house, and again, another part of the package that you get with the step-by-step retrofit, passive house retrofit process is that there's an interrelations table. I don't expect you to read this, by the way. So I've just got a little example. So what it does is it has some steps along the top and on the side, and it starts to interrelate them, and it starts to help you think about what might you need to do. So I filled in the text, but it makes you say, oh, what am I going to do where the internal wall insulation meets a ventilation system, and which one's going in first, and should I do one part of one of those before I do the other part so that I get the order correct. So in this case, it was just highlighting that before the MVHR system was installed, I might think about installing the internal ducts and IWI before putting the MVHR unit in, and actually just thinking about what is that actual sequence of works. So that was actually really helpful to do that in a number of cases. You know, I mean, I think we all know that a large part of building processes are, I know roughly what I need to do. I'll start doing it, and then I'll have to go down to the builder's motions to get the bit that I didn't do. And then very often you end up in a bit of a dead end because you've sort of got so far and you think, oh, if only I'd done that. So I think the more thought processes we can introduce into sequencing of works, the better. So we've put MVHR into the house. We used a radial system. So they're much smaller, 75mm flexible ducts. I think putting a branch system with much larger ducts and the silencers associated with them would have been really quite challenging. So I installed the whole system myself. My wife and I put the unit on the wall. It's quite heavy. So we lifted it up and hung it on the wall, and then drilled all the holes and put all the ducts in and set it all up, and then EnerPHit commissioned it. And we now have a lovely MVHR system in the house and really fabulous air quality. So we're really, really happy with it. There's an example of some of the holes we dug and a sort of moment of junctions working through. I could talk at length about all that, such as the air tightness to the loft and the single duct that goes into the loft and why we did that, and whether there's any problems with it. We actually put insulated duct, insulated pipe. The duct has got special insulation that's the shape of the pipe around it, as well as being embedded in this insulation just for added robustness, given that it's the one duct that goes outside the thermal envelope or outside the air tightness envelope. So there's our MVHR, which is actually there's a bat wing seal around the door, and there's a bit of acoustic absorption inside here, and you don't hear it in the bedroom at all. So it's really, acoustically, it's really great. And just if you're interested, that's a Zander Q350. So I got my son to do some drawings of the MVHR, and I'm quite impressed with his layout in the middle there. He knew that the ducts wiggle through the house, and he's certainly got that. And he's definitely got where the supply air is coming from the left. And so he's annotated it with lots of little blue arrows. So he's been doing posters of our house as part of him learning about the processes that we've gone through and feeling that his house is special, even though it's not finished. And he actually shared these with his class at school. That's filters, clean at the bottom, dirty at the top. So that's what we're stopping coming in our house. And we've been monitoring air quality and, very aware that CO2 has a huge impact on our lives, and I'm very passionate about school classrooms and getting improved air quality. And this is actually a school classroom just a few weeks ago going. You can see there that purple bar is where it went over 2,500 parts per million within about 2 hours, by about 11 o'clock. That's because it was a rainy day. And of course, that's impacting on the teacher and the children. This is very interesting. This yellow peak here, this big bar, is actually from 2019, and it's PM 2.5s, which are particulates in the air, as small aerosols. And that was when we had to cool the house down with natural ventilation. So the MVHR wasn't able to cool the house down, so we couldn't get large enough volumes of air through the night to bring the temperature down during a heat wave. So we had the windows open much more, and look what a difference it made to the air quality of the house. So really quite incredible. This slide shows the importance of ceiling air tightness, and there was a crack in the wall, and very clearly there'd been a very long period of endless, constant leakage of warm, moist air from the bathroom up into the loft. And there's your 100 mil of insulation, and it's just been gradually this ever-growing mold patch spreading across the ceiling. Pretty grim. So we removed all the plasterboard and we put in vapor block board. So it's a very robust board, which is vapor and airtight, with tape between the joints and then tape plastered into the walls. So we basically created a perfect rectangle across the whole of the top floor that we know is incredibly robust and airtight. There's the super loft polyester insulation going in with the loft store floor system, which is a really great system. And then there's a deck on top of that. So that was about 350 millimeters of insulation. So there's single glazing in a neighboring house, massive overheating, massive condensation and huge heat losses. So really, really poor a bit of building fabric. And that's what our windows look like at the back, pretty grim. And then there's our roof with frost on it, nice bit of frost showing that the insulation's working well with our triple glazed windows. So incredibly comfortable, really real pleasure to have such high grade windows. And really lovely to be able to get masses of natural ventilation if you want it, with these huge inward opening windows and flying mullions. Overheating's been an issue, and I wanted to develop a system that was homegrown, bespoke, and a bit fun. So I developed this idea of solar shading, and I worked with a sailmaker to produce some bright yellow sails that are bespoke to each window. and that was Timber and Tent. Roger Brisley is a great guy, and they're beautifully made. We went for a complementary color for the edges, and I've installed them myself. I just put some screw eyes into the brickwork, and then we just basically pull them tight. I think it's called a half hitch. I'm not very good with the terminology of knots, but it works. Just pull them tight and then lock them in place. And so basically, when it's really, really sunny and really, really hot, it's usually quite bright as well. So we get this lovely warm glow in this room. But we cut out all the sun, and it made good couple of degrees difference to the internal temperature, which is really what you want when it's a real heat wave. And it's a bit like going sailing. It's sort of hoisting the sails. It's a bit of fun. Yeah, quite enjoyable. So we put cork insulation in. At the moment, it's exposed, and we really enjoy this natural finish. There are two types of finish of cork, one more friable and one with a much finer finish. So we've used the finer finish on the inside with an air tightness layer behind it, and then another 100 mil on the inside of that. And we very carefully set out the joints to make sure that there was a finish layer and that no joints were overlapping to the layer below. And I even set it out on the driveway. And then we saved all the offcuts, and then we managed to insulate a whole nother room with the offcuts, and that was in the wall where there's a cavity wall insulation, so we weren't worried about the thermal bridges of more joints. We've also put sensors in throughout the house. I showed you what they look like earlier on. And normally I would put sensors in during the building works, but here we retrofitted them after we put the insulation in. So there's that wall section of the cork with the air tightness layer between the two layers of cork. And there's the sensor going into the hole. And there's some data. So this is what the OmniSense HydroTrack system shows. And you can see on the left where the sensors were put in and mortared in. You can see the relative humidity went really high and then it dropped down. And then we're getting really robust readings. I think 60 and 65 for the middle of the wall on the cold side of the insulation is really very good. So a lot of the drawings were done by watercolor. So I sort of, during those 2 years of building, I would actually draw a detail in pencil in the week. And as the week would go on, I'd sort of watercolor it in and say, right, that's what I'm going to build. And then I'd build it on the Sunday. That's the front porch, quite a tricky detail there. And then, I want to talk a bit about the challenges of retrofit. This is a bit more kind of reflective. It's about how do you balance air tightness and ventilation through the retrofit steps. And in this case, we have these absolutely rotten UPVC existing windows that all the seals had gone, the ironmonger is all floppy. It's just completely useless. So in some cases, we just use some white tape and just tape them up. And they're just like that now. Don't need to open every one of them. And then in other cases, we actually made sure that we specified a night vent. And a night vent is where you can crack a window open by about 3 millimeters. And that's a 45-degree turn of the handle. And so that gives you some nice trickle ventilation that is roughly right, meeting building regs for background trickle ventilation. So that can give you your interim infiltration and sort of freshening up of air before you've actually installed a ventilation system. So that's just a tip on that strategy. I think it's definitely challenging managing your creature comforts as you're working. It's sort of like you want to insulate a wall, and you've got to do things like move curtains, and then you finish building, putting your insulation up, and then you've got to hang the curtain up because your son's got to sleep in there every night. Things like that, which are quite challenging. Lots of hoovering as well. Then I think it is quite tricky to sequence the works. You don't just insulate a wall. You've got to think about those reveals. You've got to think about the junction to the floor. You've got to think about pulling up a floorboard and getting into the wall. So it does start to affect the floor below. Just to make sure there's no washing hanging out as you start opening up. And then there's sort of some tricky moments. So this is where this was a bit of an experiment where I used a bit of horsehair and lime mortar and granulated cork to form a kind of semi-insulated, airtight fill between a joist and the wall. Quite tricky detail where you have that very thin space between the joist and the wall. You need to make that airtight. So this is about pouring in a slurry and then letting it set and getting the horsehair in to give it a bit of robustness and not cracking. And then there's things like storage, and I don't think we got storage right. I think I probably would have got all our storage sorted right at the beginning, and then we would have had a sort of zone where everything can go and be dust free, and we never quite cracked that one. This is meant to be my wife looking upset, but she didn't manage it. It's very annoying that a lot of natural insulation materials are not available locally, and I hope this does change over time. You know, you can pick up your Cooltherm or your Celotex, maybe not now, but you know, generally that's just at the builders merchants. But your lowest embodied carbon insulation material, cork, is not always available, and so when you order it, you really want to order all of it if you can, to reduce delivery carbon and delivery costs. And then there's a question about moisture landing zones, which I think is an Ian Maudit phrase that I borrowed. And that really says, if you have some areas of your house that have high humidity and are very cold, and air is, the outside wind is pulling over the house and is extracting air in certain locations, are you creating a risk of an increased risk of moisture landing on very cold parts of the building fabric, lots of warm moisture? So if you have a very leaky space around joist ends and you have very high humidity, are you creating a problem? I haven't really experienced that as an issue, although I do think it can be mitigated by just managing your internal moisture levels. And it's just something that I think if you are a DIY retrofitter, you're probably already aware of these issues, and you probably know how to ventilate and how to keep your relative humidity down. So the upsides of all this are that, this is my son saying, finished cork wall, the end, now we feel warm, is the bodily experience, the improved comfort of each step. It's really quite a radical experience. It's really lovely to live it. You know, I've been designing it for years, but in this case, it was like going from really crap UPVC double glazed windows to high-end triple glazed windows, and just feeling that difference. And it's really great. It's really nice to get closer to natural materials. It's been a wonderful learning experience for my son. And it's been really nice to share. So I've had lots of Passive House students around. We had the house open for International Passive House Open Day. And we also leafleted the whole area. I mentioned earlier on that there's a lot of similar houses, and we really wanted to just create an opportunity for retrofit action locally. So that's us leafleting. And then, you know, and then we completed a room, which was a significant moment. We've now completed a couple more, and it's nice that, say, Grand Design started to get interested in this. And you know, now we're thinking, well, how do we scale up? So there's the one. Can we think about the 10, or maybe the 20, or maybe 100 houses locally? Maybe more like 2,000 or 3,000 in the local area. Maybe we should be thinking about the whole of Lewisham, or London even, and maybe the whole of the UK. So it's a big question, and I'm going to answer it very briefly in the presentation. So it's 7 o'clock, so it's still okay for time. So just got a little bit about my thoughts about scaling up, and you know, on the theme of this presentation, it's very unlikely that all homes can be retrofitted in one phase for a whole plethora of reasons. So I think step by step does offer a great opportunity to lock in excellent steps at each stage. And just to go back to what I said at the beginning, this is after you've sorted out your rainwater goods, your roof, your flashings, everything else, all the boring stuff that costs money, but is terribly important. And I think we might start to think about trigger points. So, you know, you put solar panels on, you've got the scaffolding up. Well, there's your trigger point to get retrofit ready. It might even be an opportunity to re-roof. So, you know, I think we should be reaching a point where if somebody says, oh, I'm getting a new bathroom, you say, oh, you are putting new insulation in, aren't you? Even if you're redecorating the living room, you are going to insulate, aren't you? So you're sort of trying to engender thought that anytime you do anything to the building, particularly kitchens and bathrooms, which are the kind of things that don't get renovated for another, say, 15 years, that you're just locking in poor performance unless you actually do something right now. So, you know, it'd be really interesting to hear from you about what mechanisms can be used to require that thermal performance is locked in at these trigger points. What kind of cultural change or legislation, incentives can be used. And I'm very interested in DIY as a concept and self-build. And you might have noticed on the slide of images of projects I'm working on. One of them is a Walter Siegel house. So I'm retrofitting a self-built house, which is really fascinating, really interesting. I can talk about that another time. And then really, I just wanted to say that making savings really is achievable. It really is amazing that we've cut 70% of our space heat demand in 4 years with pretty low funds and a bit of Sunday work. It's been fun. There have been some challenging moments, but it's very, very achievable. And it's really nice. So this is a drawing I did for the ASBP Award, the Association of Sustainable Building Products, and we're really delighted to win that for the house. And that was partly to do with the overall approach we took with everything on the house, including cutting up the tree that I told you we got cut down. We actually got it cut into 2.6 meter lengths, and then we had a mobile sawmill come in, and then we air dried it for 3 years. And then at the start of the lockdown this year, we actually built a deck. And so there's now a deck made from Leylandii timber next to where the tree was cut down. So there's a really nice story with it. Now, it doesn't always go right. This is a piece of leftover ductwork that I was really keen to find a new home for. So I put it on Freegal, and somebody said she'd love it. And so this lady came over and she was really delighted with it. And I asked her where it was going. She said, "Oh, it's going into my house." And I thought, "Oh, great. Okay, well, where's your house?" And she said, "Uganda." So she was actually going to go and put it into a container, and it was going to get shipped out to Uganda, and she's going to put it in her house in Uganda. So there was me trying to locally reuse something, and it was actually going on a 6,500 mile journey. So I'm gonna whiz through this. This is some processes for a step-by-step deep retrofit of a mid-terraced house in Bourneville. And I'm just gonna very quickly go through them. I just want to share some of the thinking that we've done. And it's really important that these processes are kind of loved. And I think it really needs the client to help. There's no way that our fees can cover this amount of in-depth love about reusing or free cycling all the different materials. But you need a client that says, I don't have to have a perfect brand new toilet, but there's embodied carbon just in that toilet. If it's pretty good, why throw it away? So it's just about changing the architectural mindset, and you get a new aesthetic, but it's still robust, and it can still be really beautiful. We're hoping this can be a beautiful, beautiful project. I just wanted to give a quick sense here of what the potential avoided carbon can be from a standard retrofit with large steel beams and massive openings and big glazed areas through to a low carbon retrofit. And this is actual measured data from the same project, just changing the design and changing the approach and the materials, where we've used masses of wood fiber insulation and the timber frame. We've ended up with a kind of negative carbon for the proposed materials for the project. So it is 7:05. If I'm permitted, I'm going to now talk about how my ideas about scaling up from the retrofit to a slightly different kind of proposition. Am I allowed to carry on a little bit?
Yeah, maybe for 5 minutes. We've got quite a lot of questions, which is
Okay,
great. So it'd be good to have a good 20 minutes for questions. So maybe
sure.
Go for another 5 minutes.
I think 5 is very achievable. So
okay.
I've just set up a new community interest company called RAFT, which stands for Retrofit Action for Tomorrow. And I've been working with schools, and this has been very much born out of my experience at home with my son and doing posters. And we've got something called the Baked Potato Challenge, where I teach the children about thermal performance and thermal continuity, and we give them natural building materials, and then they produce an enclosure for a baked potato following specific rules. And then the school bring in hot baked potatoes, and then we enclose them in their houses, and then we come back 2 hours later with a thermographic camera and a digital thermometer, and there's winners are chosen. And then what that has led to is me scaling up, and we're actually about to start work on 5 schools, but we just spent about 6 months working on a school retrofit program and education program. And we had a wonderful zero carbon assembly in October, and you can actually see that if you're interested. And the idea of RAFT is that we deliver professional retrofit services, but at the same time, we engage all the children and the school community. And in the words of a head teacher recently, she thinks she can influence up to 5,000 people. So my thinking is that if we can retrofit all the schools in the UK to a really high standard, we can also influence all the homes in the UK, and they may then carry on the retrofit revolution. So we've been working with Dave Edwards, who wrote the Design PH SketchUp plugin, and we did some thermal performance analysis of the school. We looked at a zero carbon buildings timeline. And we also looked at scopes 1, 2, and 3 carbon. So not just the building, the carbon emissions of the building, the gas and the electricity, but also that of procurement and transport within the school. We commissioned some cartoons to try and describe how we worked with the school, and some other drawings that would help everybody understand why we've put in MVHR and how we're externally insulating the buildings, and then a kind of vision for what the school might look like with allotments on the top, and rain gardens, and insulating the buildings, and then sort of achieving zero carbon status. So this is a zero carbon plan for a school. And because it's been so successful, we've just been asked to do 5 more of these. So we've started today on working on a zero carbon plan for five more schools in Lewisham, and we're gradually growing. And our ambition is very high. We are actually planning to submit for the EarthShot award run by Prince William. And we're really hoping that we can scale up and make a really big difference. Now, there's a film that we may or may not be able to watch now. It doesn't matter if we don't now, but it's on, if you go to Vimeo and Retrofit Action for Tomorrow, there's a film, which is the one here on the left, which is only 4.5 minutes, but it's quite moving because you hear from the children their experience of the workshops and their vision for their school. And if you've got an hour to spare and want to learn more about the proposals for the school, we've got the recording of the zero carbon assembly. So that's it. Very happy to dive into questions. So I don't know if I should open up the Q&A, and maybe I'll stop the share.
Yeah, I can also invite people to ask their questions live, which might be nice. So if we start from the top, Professor Michael, I'll just invite you. Feel free to put your mic on, Michael, and your video if you like. You don't have to.
Okay, can you hear me?
Yes.
Yes, we can.
Right. Now, I've made 2 points here, and they are kind of related. First of all, I applaud the work that's being done. And I'm very impressed, of course, with the work that you've committed to in your own house and in your parents' house, I think you said.
Yes. Yeah.
I'm hoping that the Passive House Trust is collecting all of this information together and building up a typology of house types and the solutions that have been applied to them, so that these can be used as exemplars, so that way beyond the clients that you can interact with, that they can reach a wider audience. But that is a sort of preamble to a rather more challenging comment I would like to make, which is which links to the typology issue. And that is, we know from the House Condition Survey that something like 70% of the housing stock is below an EPC standard of C. So that suggests that something like 15 million houses are going to be addressed in some fashion over these next 10, at most 15 years. And I would argue that because that activity will be resource constrained, it will not allow that kind of deep retrofit of the kind that you would be describing. And indeed, if we were to pursue that as a strategy, it would effectively mean that very many fewer houses would actually be improved and would leave behind a lot more people in fuel poverty than if we'd adopted a more modest program. And I pick up the points you made about this being a package of measures. If we took that package apart and looked at the elements, we will see that some of those elements are pretty quick fix. You get a big bang for your buck. You save a lot of kilograms of CO2 per pound invested. But as you go further, the amount of additional CO2 that you reduce becomes less and less.
Mm.
And then even if you take that package as one which you think is a reasonably affordable in the context, you do that today and you will save a certain amount of kilograms for CO2. Deliver that same package in 5 years' time, and the amount of CO2 that will be reduced will be markedly less. In 10 years' time, even less. And if you attempted to do that in 15 years' time, you will not save a single kilogram, because the energy supply industry during this time has been fairly rapidly decarbonizing.
Michael, if you don't mind me interrupting, sorry, do you have a question for, I might be missing the sort of question for Harry here.
Well, it is a comment, but the challenge is, what can you take from your program and the experience you gain in doing it that can be delivered more broadly, recognizing that the economies of scale are working against you progressively?
Thank you. That's a great question.
Yeah, well, I think you know, I share pretty much all of what you said. You know, the world, I live in my bubble, and my bubble is at the scale of buildings and trying to make a difference, and trying to push boundaries where I can. And I think when you zoom out and you look at the country as a whole, I'm sure you would have picked up that I have said I do not expect all houses to be delivered to Passive House standard. In fact, it's inappropriate for many reasons, both based on the skill base, also the moisture robustness of properties. So there's a lot of reasons why you wouldn't do what I've done in my house to all properties, and I hope I made it clear that that's really not what should happen. You know, the takeaways are that when you can lock in some good performance, you should take that opportunity. That's my first suggestion. And the second is that you need to look after your properties. And at the moment, we don't even look after our properties, let alone insulate them. So, you know, I share a lot of what you said. I think you put it very elegantly. And I think that those big scale questions are very important and should be addressed and should be part of all this debate. So, you know, thanks for raising it. And yeah, you're on the right track. And, you know, I want to be part of that debate. I'm not a macro thinker. I get stuck in and do things, and you know, I'm sort of excited about making it more of an impact through schools and influencing communities. And you know, how we deliver this is such an important question. And you know, there's people that work on that scale, and that's not really my bag. So you know, I'm trying to do what I can in an architectural building scale. But thanks for the questions, pretty good.
Thanks, Harry. So we've got one from Rebecca, which is on a bit of a different scale. Go for it, Rebecca.
Hi, I've also spent lockdown getting my house kind of retrofitted, and I found it really quite frustrating. And one of the things I've found really impressive with your presentation is how you've managed to get quantitative estimates for how effective your interventions will be, and then you've gone about and measured performance afterwards. So my specific question was like, have you got advice specifically about the humidity sensors you mentioned, but kind of more generally, where we would look for advice on kind of estimating how effective measures will be for the PHP, I guess, but then measuring whether they work and whether you've got a problem with things like moisture. So let's be clear about what they're measuring.
Generally, when they're in a room, they're measuring overheating or temperature and humidity. So we might be looking at temperature asymmetries in a house, you know, just differences front and back, some sunny side, you know, south side, north side, temperature differences vertically. But then when they go into walls, we're very much looking at the hygrothermal performance of the wall. We're looking at, do we start getting a risk of joist ends starting to get higher levels of moisture? So in that case, that's why we put the little timber block on. I think in terms of advice, I think the Carbon Light Retrofit course by the ACB is probably mentions sensors and monitoring a lot. So I think that would be an excellent course to get more knowledge on. I don't know how much information OmniSense give on their website. You might want to look there. There might be a few case studies. I'm certainly happy to share a drawing if you email me. I've got a little drawing of how I would install it in a wall. So I'm happy to share that. So there's not a huge amount of information out there. There might be some historic England papers. I know that there's Caroline Rye's brilliant work for the SPAB. She's been monitoring a number of houses for a number of years, and there's lots of really good papers on it. So somewhere in between all that, I'm sure you can get some good advice.
Thanks.
Thanks, Rebecca. I was going to work down the questions from the top, but actually there's one here that relates to something you were just talking about from Matthew, and I'll just read it out. It's, how do you treat the joist ends? It sounds intrusive.
Yeah. Deep retrofit can be quite invasive. So it varies. I think I mentioned that on my mum's house, we didn't insulate, we didn't tape the joist ends to the wall. In a standard situation, if we've got full access to a house and we can expose joist ends, we would take away the ceiling, cut out the ceiling from below, take a floorboard off from above, and then we would make sure we've plastered the wall, filled the gaps around the joist, and then we would tape the end of the joist into the plaster and plaster over the tape. So we would know that we've got a really robust, airtight junction there. Now, the reason why we would tape joist ends is that if you do have warm, moist air in your house and you do have negative pressure on the other side, warm, moist air will be being pulled out of the house on one side, and they could potentially become a moisture landing zone in those areas. So generally, it's sort of more robust to do that, and so we would use tape to achieve that. And it is quite invasive. It's also quite therapeutic. It's quite nice to do.
I think that's answered your question as well. Someone's got an email name. I mean, and there's also just meant that some projects cut the joist ends and put a beam across, but I assume that you don't have to.
Yeah, no, you can do that. That's a much deeper structural solution. And I mean, we're monitoring joist ends. We've been monitoring them for 7 years now in one property and haven't noticed any issues. So, I think I wouldn't spray, by the way. I'm a bit less keen on sprays, on airtight sprays. Okay. I quite like the idea that you can rip off something and reuse it at the end of its working life, and thick layers of plastic, yuck.
So next question is from Abigail, if you'd like to ask your question.
Oh, I think I was just asking how noisy the MVHR was, but Harry already answered that.
Okay, brilliant.
Yeah. Sorry. Hi, Abigail.
Hi, thanks, Harry.
No problem.
There's a question here from Amma. Let's see. And actually, I was going to answer this, but I didn't. So it's a question. Well, I'll let you ask yourself, Amma.
Yeah, for the Green Homes grant, do the products have to be BBA approved? Because I heard something at the weekend that they don't have to be BBA approved, so I'm not sure.
Yeah, and I've heard that some of them do, but I don't actually have knowledge across. And I don't know if you have the answer to this question, Harry, or not, how much you've engaged with Green Homes grant.
I have heard that they do need them, so that's what I've been advised. But I think I know some builders that have been going back to some of the to say Swiga or Sega, some of the cavity wall and guarantees schemes that they might be able to help a product through. But I haven't really got that involved with the Green Homes grant because it's so hopeless.
And actually, I'm going to skip through at that point to Katrina's question, because she also mentions the Green Homes grant, and this might be a good point to bring it in if you'd like to ask your question.
Hi, Harry. Thank you firstly for the talk. It's really, really insightful. Yeah, just on that note, I was asking, well, first you said your intentions with scaling up are admirable, but what with the government's recent new Green Deal drive, obviously given what happened or has happened previously, how do you think we can mitigate against poor retrofit with the harmful materials, and also, I guess on that note, poor retrofit that has negative effects on a large scale? Thank you.
I think it's such a good question, and you know, I mean, on a really simple level, I just hope sharing sessions like this, you know, just part of that overall solution that we're building up more knowledge, and you know, we know that lots of progress is being made. You know, we know with PAS 2035 and the growth of retrofit coordinators as a thing, and it's so nice to see Carbon Co-op looking for you know, more retrofit coordinators and architects to start to carry out their projects. You know, I think when it's coming from Carbon Co-op and from and out of more grassroots organizations, you can feel that the profit-driven motive isn't there, that the motive is to do the right thing. And if clients and architects are motivated to do the right thing, or retrofit coordinators or builders, whoever it is, and it feels like scaling up is altogether more achievable. You know, I'm feeling really positive about things at the moment. I'm just finding builders I'm working with are much more engaged than they used to be. They're really keen to learn. In fact, they're fascinated by it. So, you know, I kind of do feel that there can be quite a big revolution. You know, I think about a kind of DIY revolution, but I think there could be also a very big revolution in the building industry, and a massive growth of skills and energy to do the right thing. And of course, we know that has to be coupled with great educational initiatives like, I don't know, at the slightly more high end, say certified passive house design, but you know, also the AECB carbon light retrofit courses are excellent, and you know, there are lots of other courses, and then all of PAS 2035 as well. So
yeah,
sure the question.
I mean, I would really echo what you've just said, and I think we need to, I think often when I've seen in Manchester some sort of people in government talk about, well, local government talk about scaling up, and they've got this kind of, our carbon budget says we need 61,000 homes next year, and they kind of think, you know, I feel like we need to put in place the structures to allow us to scale up, including sort of respecting and supporting and growing the construction industry in this area, so that, you know, maybe in 5 years' time we might be able to achieve thousands of homes or more, tens of thousands. But this year, let's like focus on starting small and growing well, because sometimes these big schemes run by quite large contractors don't have that kind of attention to detail that you need, really. I mean, that's obviously it's more complex than just that. It's a very complicated system.
Yeah, I'd like to just add something, which is that both in terms of the Green Homes Grant and the current public sector decarbonisation fund, there's a big pot of money, right? And we know the money is all running out because everybody's diving in, and I think the whole structure of funding these processes is predicated and is constructed in the wrong way. You know, for a start, having a deadline, which means everybody's rushing towards it, and
exactly.
And it's totally overloading contractors in a short period of time, but they don't have any knowledge as to whether it's going to carry on. So they might not even take more people on because they don't know that market is going to continue. So
exactly.
You know, so much of this goes back to politicians and to civil servants, and how do they set up these schemes? And the same goes for public sector decarbonisation fund. £1 billion, and you've got to build it by September 2021. And it's like, wow, you know, if ever that was encouraging a one quick hit measure that may not be appropriate, I don't know what is, you know. So to answer, I can't remember who asked that question. I can't see the question up on the board anymore, but to answer the question, I think that maybe people like me have to call it out, because I'm actually being asked to go for some of that money, and I'm actually putting the brakes on. I'm actually saying, look, I know you want the money, and I know you want to get stuck in, but let's sort out the gutters, and let's do the things that we really need to do. And it may mean that we're doing less work. It may mean that things happen a little bit less quickly, but at least we're going to be doing it in the right way. So it's sort of balancing money and urgency with a bit of common sense.
Yeah. So I just want to say we're approaching the end and we've got so many questions. We might not be able to answer them all right now, though we might be able to, you know, after the session potentially. So I'll just ask a few more and then we'll have to stop. But I won't invite people to speak anymore because I think it just speeds it up a little bit. So we've got a few here from someone called an anonymous attendee. One is, how do we persuade unconvinced clients and how do you justify the cost spends versus returns?
Oh, let's just forget that whole conversation. I've had enough. I just, you know, I think it's just so naive to just be thinking about the cost benefit of just, you know, insulation's got a 30-year payback. I'm really bored of that. Sorry if that's a bit,
No,
but I just think, you know, I've had enough of that debate. It's not the right question. You've got to think about the bigger picture. Think about your own health. Think about your own air quality. Just don't think about pounds, please. You know, not at this
well, also
level.
another way to think about it is, you know, you wouldn't be looking at returns when you improved your home or bought a new car or improved your kitchen, or, you know, sort of, I think it's definitely a type of way of thinking that this income, you know.
And you know, it should be aspirational to have a really high performance, healthy home. You know, that should be something that we all think, oh, wouldn't it be great to have that?
Well, that's comfortable and healthy too. So there's a question here, just a simple one. What material are your window frames made from?
Wood.
Okay, great. There's one, I'm not sure how far you should or can give advice. Someone here has asked for advice. So I'll ask a question, just, you know, but feel free not to be able to answer it. So Wynn's asked, I have solid stone external walls, not plaster on the outside. Walls feel damp inside. Thoughts on wall insulation and damp solutions? And so, yeah. Well, normally at Carbon Cork, we say we can't give specific advice until you actually see someone's home, particularly if you're an architect, etc.
Well,
but
you know, I mean, it's you know, I could ask you questions. I won't give you answers, but I can give you questions, which are: do you know what the source of moisture is? Do you have a French drain that reduces the hydrostatic pressure on the wall and will reduce the amount of moisture rising through the wall? Do you have high internal levels of humidity? Do you have extract ventilation inside? You know, try and get to the bottom of those first before you start throwing on any insulation. But if you do end up throwing insulation on, don't throw too much on, and make sure it's all vapor open. You can dry both ways.
Okay, thanks, Harry. So I think we'll have to leave it there with the questions. I'm sorry for those of you that haven't been able to get your questions answered. For the last part of this session, what would be really great, and Harry also might be able to answer some of your questions in the Q&A if he's got some time. But for the last part of the session, so we often do a sort of evaluation board, which is sometimes quite fun because you get to see what other people have said. So I'm just gonna, if I just fiddle around my screen, I'm just gonna share my screen where, let me search for the right thing. I've got so many tabs open, it's not that helpful. Yeah, or maybe actually, Harry, do you want to answer some more questions while I
work sure out? Okay. Okay, so the cavity walls. Yes, I think if you're putting insulation that is capillary active and very hygroscopic, which means it can hold water vapor, then it is dangerous. I mean, cavity walls were brought in to reduce moisture levels in walls, and they actually started on the coast where there was more driving rain. So that, you know, there's a very good reason for cavity walls. And I think just spraying a kind of fibrous material into a cavity wall is very dangerous, and it's something that I'm incredibly careful about. What I put into my walls is not something I'd ever do again. So it was EPS beads, and that were blown in with the glue. And you know, it's definitely robust in terms of moisture, because if any water does get in there, it will run down the wall. And we know that they're not hygroscopic, so they won't absorb any moisture. So from a moisture point of view, it's really not a problem. But I don't like the end of life scenario of lots of EPS beads, and you know, I would definitely go for something that is more like a free flowing kind of glass bead or something now. Something that is still not hygroscopic, but that can flow. So yeah, so I share that, the danger associated with cavity walls.
Thanks, Harry. Okay, so I think maybe we'll wrap up here, but I've shared my screen. Hopefully you can all see it. So this is a participatory board tool that you can all get involved in. So on the chat box, I've sent a link. So if you press a link, you can join the board and you can see everyone else looking at the board. And if on the left-hand side, there's something called sticky notes. So if you press that and pull it across, you can just press it. It allows you to write things. So you can write a comment. I will write one here. Super interesting presentation. I definitely really enjoyed it, and I particularly liked your story style, Harry, of sort of explaining how different parts were. But if you're up for leaving feedback, good things, bad things, any recommendations, if you fancy sort of rating it 1 to 10 for us, it's just really helpful for us to just get a sense of how these, whether these sessions are valuable for people, how we can improve them, how we can change them. I'm sure Harry would also appreciate some feedback.
Yeah, definitely.
So I will leave this open for everyone to just play around with, and it'll be open for the next half an hour or so. But for now, that's the end of the session. I hope everyone has a really good evening and a good dinner. And thanks again, Harry, for giving us your time and yeah, sharing your experience. It's really valuable.
You're welcome. Thanks for inviting me.
Great, thanks.
So I'll try and give some quick answers to Q&A before dinner.
Okay, you don't have to. I can also, it's up to you.
I'll dive in a little bit and just throw in a few, quick one-line answers.
Okay, great. Oh, well, thank you.